Introduction to Acids and Bases. Let us start the session with Introduction to Acids, Bases and Salts. The objective of the session is to learn about the acids, bases, and salts with their properties, and their identification using pH scale and indicators. Before we start our session, let us recollect few concepts which we have learnt in earlier sessions, that is, about the chemical elements and their properties. As on year 2006, 114 chemical elements are identified. These chemical elements are combined to form many compounds, or substances, or solutions. Based on the chemical properties, all the compounds are classified into three groups. The three groups are acids, bases, and salts. Here note that, by the end of the year 2011, 118 elements are identified. Let us discuss about each group in detail, with their uses in our daily life. First, we will learn about an acid. An acid is a substance which dissociates, or ionises, on dissolving in water, by producing hydrogen ions, that is H+ ions, in aqueous state. For example, hydrochloric acid, it is in the aqueous state, it dissolves, and gives hydrogen ions, it is in the aqueous state, plus chlorine ions, it is in the aqueous state. Now we will discuss about base. A base is a substance which dissolves in water to produce hydroxide ions. Or, a substance which neutralizes an acid, that substance is called base. For example, look at the chemical equation for a base. When solid state of sodium hydroxide dissolves in water, it gives sodium ions plus hydroxide ions in aqueous state. Now let us move on to salt. A salt is a compound formed from an acid by the replacement of the hydrogen ions in an acid by a metal. Examples are sodium chloride, that is NaCl, calcium chloride, that is CaCl2, and potassium chloride, that is KCl, etc. Here note that a solution in which the solvent is water is called an aqueous solution. Few examples for uses of acids are hydrochloric acid, that is HCl, is used in gastric juice. Sulfuric acid, that is H2SO4, is used in car batteries. Chlorogenic acid, that is C16H18O9, is used in coffee. And acetic acid, that is CH3COOH, is used in manufacture of plastics. Now look at the examples for bases which is used in our daily life. Sodium hydroxide, that is NaOH, is used in making of soaps and drain cleaners. Aluminium hydroxide, that is AlOH3, is used in making deodorants. Magnesium hydroxide, that is MgOH2, is used in antacids. And ammonium hydroxide, that is NH4OH, is used in ammonia. Examples for salts used in our daily life are sodium chloride, that is NaCl, is used as principal extinguishing agent in fire extinguishers like Metal-X and Super-D. Calcium chloride, that is CaCl2, is used in drying pipes, and potassium chloride, that is KCl, is the logical alternative to sodium chloride in water softening. Now, let's see the identification of acids. We can identify the acid by changing the prefix and suffix of the substance. Rule 1. Hydrogen will be listed first in the formula for most of the acids. Rule 2. If an anion is attached to hydrogen, and ends with IDE, put the prefix hydro, and change IDE to IC, acid. For example, HCl acid consists of hydrogen ion and chloride ion. In this acid we observe that chloride anion is attached to hydrogen, and this anion ends with ide. On adding hydro to the anion, and by changing IDE in the anion to IC, we can identify or name it as hydrochloric acid. Example 2, H2S acid consists of hydrogen ion and sulfide ion. Here we observe that sulfide anion is attached to hydrogen, and this anion ends with ide. On adding hydro to the anion and by changing ide in the anion to IC, we can name or identify it as hydrosulfuric acid. Rule 3. If any anion has oxygen in it, then it ends with ate or ite. Change the suffix ate to ic acid and ite to aus. Example 1. Nitric acid, that is HNO3, consists of hydrogen ion and nitrate ion. Here, nitrate, that is NO3 anion, contains oxygen in it and ends with ate. On changing the suffix ate to ic, we can name or identify the acid as nitric acid. Example 2. Nitrous acid, that is HNO2, contains a hydrogen ion and a nitrite ion. Here, nitrite, that is NO2 anion, contains oxygen in it, and the anion ends with ite. On changing the suffix ite to aus, we can name or identify the acid as nitrous acid. Next, rule 4. If an acid has one oxygen more compared to ic acid, then add prefix pa. Example, HClO4, perchloric acid. Using rule 3, we know hydrogen chloride is an acid, that is chloric acid. To this chloric acid anion we increase one more oxygen, that is ClO4. So, for chloric acid, we add PER as prefix in it. Rule 5. If the acid has one less oxygen compared to aus acid, add prefix hypo. Example, HClO, hypochlorous acid. Using rule 3, we know hydrogen chloride is an acid, that is chlorous acid. To this chlorous acid anion we decreased one oxygen, that is ClO. So, for chlorous acid, we add hypo as prefix to it. Rule 6. Acid formula is in the format of HX, or HAXBOC, or ends with COH. Example 1. Brahmic acid, that is HBr. Here HBr satisfies HX formula format. Example 2. Acetic acid, that is C2H4O2. Here C2H4O2 satisfies HAXBOC formula format. And example 3. Acetic acid, that is CH3COH. It is an organic acid. Here CH3COH satisfies COOH formula format. Here note that, by applying the given rules for the given substance name or formulae, we can conclude whether the substance is acid or not. Till now we learned how to identify an acid. Now let us move on to identification of bases. Rule 1. The name of the cation, that is metal, is followed by the name of the anion, that is hydroxide. Example 1. NaOH, that is sodium hydroxide. Here, the cation Na+ is metal, and it is followed by the name of anion OH-. Example 2. CaOH2, that is calcium hydroxide. Here, the cation Ca+, that is calcium, is a metal, and it is followed by the name of anion OH-, that is hydroxide. Rule 2. The name of the suffix is IUM or IA. Here, some of the substances come under bases which do not contain hydroxide ions. For example, consider a base NH3, that is ammonia. Here, the name of the base ends with IA. By applying these two rules we can identify whether a given substance is base or not. Next, identification of salts. Rule 1. The name of the substance ending with IDE, ate and ite are called salts. For example 1. NaCl, that is sodium chloride. Here, the name of the substance contains IDE, so it is salt. Example 2. ZnSO4, that is zinc sulfate. Here, the name of the substance contains ate, so it is salt. Please note that, by applying the given rules for the given substance name or formulae, we can conclude whether the substance is base or salt or not.